So whatever you have learnt is first and second part of chapter 1, children. That is electric field is first part, electric potential is your second part, third part is electric flux and Gauss's law. That is what is the third part, and fourth part will be capacitance. So flux, what will be flux? Flux is nothing but number of electric lines crossing per unit area is what is called as flux, and it is always an scalar quantity because I am going to find out only the number of lines crossing there, and it is denoted by phi. Actually flux is there even in magnetism lesson also, magnetic flux there. This is electric flux. So it enhances, how does the chapter enhances is that if I am going to find out a closed surface, so this is what an irregular closed surface is. This is an regular closed surface, a sphere, but this is irregular closed surface. There I will take a, this is what the electric field is E. There I am going to consider a small Gaussian surface, a small surface to which a perpendicular is drawn to show that is how the area is calculated. So phi is given to be equal to closed integral. This closed integral says I am going to find it only for a closed surface. E dot dA. dA is nothing but surface area. E is the electric field. That is how Gauss stated the law as he came to a conclusion what will be the phi E. So phi E, I know the relation or by definition. This is given by definition. E dot dA. dA is nothing but dA cos theta. So if cos theta, this theta value is going to be equal to 0, then it is 1. Cos 0 is 1. It turns to a value of phi E will be equal to E into dA, because this integration is done only for the area, because I am going to consider a sphere of radius r, then the small area to be the Gaussian surface acting perpendicular to the electric field. This sphere is what is called as spherical Gaussian surface, where its surface area, sphere has a surface area of 4 pi r square. This you have learnt in a 10th standard. Then E, electric field that we have already derived, E is equal to 1 by 4 pi epsilon naught q by r square. I just need to substitute that in this place, and then what happens, r square gets cancelled, 4 pi and 4 pi will get cancelled. At last you get q by epsilon naught. Phi E is equal to q by epsilon naught, where this flux is going to depend on the charge that you are going to apply. It doesn't depend on the area, or it is not going to depend on anything else other than the charge which is going to be there in the surface, and also to be the, this is permittivity of free space. So this is what the Gauss's law is. So there is a video through which you can even more clearly understand the concept.
So please do watch it and enjoy learning physics.
Electric flux. Electric flux through an area in an electric field may be defined as the total number of electric field lines crossing through that area normally. Let us now get an expression for electric flux through a plane surface of area S, and also through a plane surface of area S inclined to the applied field. Case 1. If the electric field is normal to the plane surface of area S, then the number of electric field lines per unit area is proportional to the magnitude of the electric field. This means that the number of electric field lines is proportional to the product of E and S. This product of E and S is called the electric flux and is represented by the symbol phi E. Phi E equals ES. Case 2. If the electric field is inclined at an angle theta with the plane surface of area S, then the expression for electric flux can be written as phi E equal to E cos theta into S. Phi E equal to ES cos theta. Phi E equals vector E dot vector S. Electric flux will be maximum when the surface is normal to the electric field, that is when theta equals 0. Phi E equals ES cos 0 equals ES into 1 equals ES. The flux is 0 when the surface is parallel to the electric field, that is theta equals 90 degrees. Phi E equals ES cos 90 degrees equals ES into 0 equals 0. Now, if the electric field passes through an element of small area ds and theta is the angle between vector E and the normal drawn outward, then the electric flux through this area ds is given by the equation d phi E is equal to ds into E cos theta equals E ds cos theta. D phi E is equal to vector E dot vector ds. Therefore, electric flux for the entire surface is given by the equation phi E equal to summation vector E dot vector ds. For a closed surface, phi E is equal to surface integral of vector E dot vector ds.
Gauss's law. Carl Friedrich Gauss, a German mathematician, gave a law named after him that gives the relationship between the electric flux through a closed surface and the net charge enclosed by the surface. According to Gauss's law, the total electric flux through any closed surface is equal to 1 by epsilon naught times the total charge enclosed by the surface, where epsilon naught is known as absolute permittivity or permittivity of free space vacuum. Let's now prove the Gauss's law for a spherical surface. Consider a hollow sphere of some radius r. Let there be a point charge plus q kept at its center. Then the electric intensity at a point on the surface can be given by the equation E is equal to 1 by 4 pi epsilon naught into q by r squared into r cap, where r cap is a unit vector directed from plus q to the surface element. Now, let's imagine a small area ds on the surface of the sphere. The electric flux is now given by d phi E is equal to vector E dot vector ds. This electric flux can be written as d phi E equal to vector E dot unit vector n dot ds, where n cap is the unit vector normal to ds. The electric flux acting outward through the surface is given by the equation phi E is equal to the surface integral of vector E dot unit vector n dot ds, which can be written as phi E equal to surface integral of vector E into 1 dot cos 0 dot ds, or phi E is equal to the surface integral of vector E dot vector ds. We know that E is equal to kq by r squared. Substituting the value of E in the equation, we get phi E is equal to the surface integral of kq divided by r squared dot vector ds. Or, as surface integral of a point on a sphere is the surface area of the sphere, the above equation can be written as, therefore, phi E equals kq dot 4 pi. But k is equal to 1 by 4 pi epsilon naught. Therefore, phi E is equal to 1 by 4 pi epsilon naught into q into 4 pi. Therefore, phi E is equal to q by epsilon naught. This is the mathematical representation of Gauss's law.